Welcome to Study Loop.
So in this question, we have a thin plastic film in the air, and then we have monochromatic light of two different wavelengths incident onto the plastic film. We have a maximum only for two particular wavelengths, and from that information, we want to know what is the thickness of the film. So let's first draw the setup. We have a thin plastic film with n equals 1.58, and it's in the air, so meaning it's air on both sides of it, n equals 1. So when light is incident, because the air has a lower refractive index than the thin plastic film, what will happen is light will experience a phase shift over here because it's incident onto a media with a higher index than the air. But it will not experience a phase shift over here because it's incident onto a boundary with air, which has a lower refractive index than the media that it was initially traveling in. So because of that, in order for them to have a constructive interference, in order for them to have a maximum, what we have is we need to have 2t equals m plus 1/2 lambda. And this 1/2 is because we experienced this extra phase shift of pi, or which corresponds to half of lambda here. So because of this extra half of lambda contributed by the phase shift, in order for them to constructively interfere with each other, we have m plus 1/2. So this number is m plus 1/2 for lambda 1. And it's the wavelength inside the material. But it's also equal to, let me call it m2, m2 plus 1/2 of the other wavelengths. Because it's a simultaneous maximum for two different wavelengths. So if I call this lambda 1 and call this lambda 2, 2t should be equal to both of them. And from this information, this question wants us to find out what t is. And we have both m1 and m2. But we get this hint that says assume successive values of m. So if we look at this, lambda 1 is smaller than lambda 2, so I would expect m1 to be a little bit larger than m2. So let's say m1 equals m2 plus 1, because we have to assume successive values of m. Then I can say m1 plus 1/2 is equal to m2 plus 2/3. If I plug that into this equation, what I get is m2 plus 2/3 times lambda 1 over n equals m2 plus 1/2 over lambda 2 over n. So n cancels, and we can rearrange it. So by rearranging these two equations, what we get is m2 m2 plus 1/2 over m2 plus 2/3 equals lambda 1 over lambda 2. What is lambda 1 over lambda 2? It's 491.4 nanometer over 688 nanometer. And if we simplify this, it's 5/7. So great. So now we can use the proportion back again. Sorry, I'm running out of space at the bottom. So we can rearrange it to have 7 times m2 plus 1/2 equals 5 times m2 plus 2/3. So that gives us 2m2 equals minus equals 4. So m2 equals 2. What about m1? m1 equals m2 plus 1 equals 3. So what it means is that what is the thickness of the film? We can find that by going back to this equation. So we can use m1 equals 3. We can plug in m1 to this one, then lambda is 491. Or we can plug m2 into this one, and then we'll get and use lambda 2 equals 288. So it should give us the same answer. So if we end up doing that, what we get is t equals, I will be using m1 in this case, t equals 2/7 times 491 nanometer over 491.4 nanometer over 1.58. And this is 2t, so for t, there is another 1/2. And that gives me t equals 544 nanometer. And that is the thickness of this thin film over here.